Good evening, everyone. We are back again with another session on assertion and reason. And today we are going to discuss chapter 10 of class 12 chemistry, which is haloalkanes and haloarenes. You are watching One Mark Solution, and I am here, Manisha Sharma from Martoday School, and the video link can be seen here. The first assertion statement that we have is iodoalkanes undergo nucleophilic substitution more readily than bromoalkanes. Now, here, if I talk about iodoalkanes, the iodine is a better leaving group. The reason is definitely explaining that. So, reason says iodine is a better leaving group due to its larger size. Iodine is pretty bulkier. So, what happens in a nucleophilic substitution reaction? If I can just quickly make you understand that. Now, whenever there is a nucleophilic attack happening, it comes and attacks, the species has to go away, and you get something like RNU and iodine goes out. So, if the substance or the halogen is a very, very good leaving group, it is a very feasible reaction. And that's what happens with iodoalkanes. Iodoalkanes have iodine, which is a better leaving group. So, here the answer has to be assertion true, and reason is a correct explanation for assertion as well. Next assertion statement that we have is SN2 mechanism leads to racemization. This is not correct. SN2 mechanism is a one-step process. It's a one-step reaction. Now, when we have one-step reaction happening, suppose you have C, you have X, you have, I'm just taking R, you have H, and one nucleophile is attacking. So what would happen? You will have a pentavalent state, that intermediate stage forming. And once that X will go off and nucleophile, there will be inversion of configuration happening. So the concept is not racemization but inversion happening. Racemization will involve inversion as well as retention. Reason says the incoming nucleophile attacks the compounds from the side opposite to the outgoing. That's absolutely correct. That's what I explained to you, that it is inversion. It will attack from the other side. So assertion here is false, but reason here is true. Third statement that we have is haloalkanes react with KCN to form cyanoalkanes. So every time you have Rx reacting with KCN, you will have the formation of RCN plus KX. And reason is KCN completely ionizes in solution. So for this, the assertion is also true, reason is also true, and reason is pretty explaining the assertion well. Because KCN can ionize itself, it undergoes dissociation and automatically forms K plus and Cn minus. This Cn minus can then replace the X and undergo the nucleophilic substitution reaction, and so the products can be formed. Fourth statement that we have is chlorobenzene is less polar than chloromethane. And reason is chlorobenzene has a longer CCl bond due to resonance. Now, chlorobenzene is definitely less polar. Why? Because chlorobenzene is resonance stabilized. Anything which is resonance stabilized will not be, polar, because the charge density is being resonating and is resonating across the entire benzene ring. And reason is chlorobenzene has a longer CCl bond due to resonance. So that is, pretty much explained here. So here, assertion is true and reason is false. It doesn't have a longer CCl bond. It has a shorter CCl bond, but resonance is definitely happening. Fifth statement that we have is presence of nitro group at ortho and para position makes nucleophilic substitution in chlorobenzene easier. That's true. Nitro group is meta-directing though. But if you already have a nitro group in the family or in the benzene ring, there are lone pair of electrons available on the nitrogen, which makes the reaction undergo, and the reaction can happen. Now, reason is the nitro group donates electrons to stabilize the intermediate ion formed by the addition of the incoming nucleophile. It's not so. It doesn't donate electron to stabilize, though there is a tendency that there will be a delocalization of the electrons happening. But nitrogen is not donating those electrons, and that's why assertion is true and reason is false. Sixth statement that we have is chloroform must be stored in dark colored bottles. That's because chlorine-based or halogen-based compounds are pretty sensitive towards light. And the reason says chloroform reacts with air to form phosgene. Now, this is also correct because CHCl3, when you react, it forms phosgene. But assertion and reason, though both are correct, they are not explaining each other. Because डार्क कलर्ड बॉटल्स में रखने का मतलब है कि वो फोटो सेंसिटिव है और फोटो सेंसिटिव का फोस्जीन फॉर्मेशन से कोई मतलब नहीं है. सो वी गो विद ऑप्शन बी. Seventh point that we have is chlorobutane has lower boiling point than 2-chloro-2-methylpropane. Let me draw the structure for you to understand. CH3, CH2, 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 Cl. Sorry, this is chlorobutane, right? And propane is propane, 2-methyl, chloro, H3, and H3. So you have these two things available with you. Now, the intermolecular forces in straight chain compounds are stronger than in branched compounds. Here, assertion is true because it will have a low boiling point. To explain this, I'll take a very simple example. If I can just, show you, this is a paper. This is a plain paper. Huh? If I just crush it and try to light it, what happens? It will burn quickly. But if I just, roll it, make it this long and burn it from this end to this end, it will take some time, to burn. Similar is this with this compound. Now, if you look at chlorobutane, if you start heating it from the halogen end, the whole compound will take some time to boil. बट अगर आप यहाँ से शुरू करेंगे तो क्या हो रहा है, सरफेस एरिया कम होने की वजह से वो चारों तरफ से अटैक करेगी हीट उसको एंड ऑटोमेटिकली वो बॉयल ऑफ हो जाएगा. So chlorobutane has lower boiling point than 2-chloro 2-methyl propane. That's correct option क्योंकि वो boiling point उसका disturb हो जाएगा. And intermolecular forces in straight chain compounds are stronger than in branched compounds. That is also correct because branch में surface area आपका decrease हो जाता है. Eighth statement that we have is benzyl chloride undergoes nucleophilic substitution through SN1 mechanism. Now, every time SN1 या SN2 आता है तो आप ये देखिए one step है या two step है. SN2 है तो one step है, SN1 है तो two steps है. So SN1 है तो two step है, benzyl chloride है तो ऑटोमेटिकली वो कार्बोकेटाइन फॉर्मेशन दिखा रहा होगा. अब कार्बोकेटाइन फॉर्मेशन की जब हम बात करेंगे तो yes, because it's a bulky compound undergoing resonance, so it is definitely going to show you SN1 mechanism. Benzyl carbocation is resonance stabilized. That is also correct. So we go with the A option. Assertion also true, reason also true, and they are explaining each other also well. Ninth statement that we have is haloalkanes are only sparingly soluble in water, which is absolutely correct. Because halogens, do not have that much of affinity, and alkanes also, they are dipolar compounds, or we may say that partially, ionic in nature, not completely. So they do have that dipole character, but not, complete character. And haloalkanes cannot form hydrogen bonds with water molecules. That is, of course, a reason. Why? Because it is not able to, dissolve in water. क्योंकि water resistance है, issue है उसमें. So A is also true, reason is also true, but they are not really explaining well. Because यहाँ पर हम जब hydrogen bonds की बात करेंगे ना, तो हमें ये भी दिखाना पड़ेगा that they have partial character. और जब ये पार्शियल कैरेक्टर आएगा तो फिर हाइड्रोजन बॉन्ड फॉर्म करने वाला जो रीजन है वो जस्टिफाई नहीं होता है क्योंकि हाइड्रोजन बॉन्ड फॉर्म तब होगा व्हेन यू हैव समथिंग वेरी इलेक्ट्रोनेगेटिव इन पिक्चर. नाउ व्हेन समथिंग इज नॉट प्योरली इलेक्ट्रोनेगेटिव, पार्शियली इलेक्ट्रोनेगेटिव, तो ऑफ कोर्स आप उसको जस्टिफाई नहीं कर सकते. सो वी गो विद बी ऑप्शन. Next statement that we have is propene reacts with HBr to form 2-bromopropane. For this, because you understand propene, it is CH3, CH, double bond CH2, and plus HBr. And so we apply Markovnikov rule here because we do not have any peroxide thing in the picture. Reason says the intermediate carbocation form will be secondary since it is more stable than primary. That is absolutely correct because in Markovnikov rule mechanism last year we have studied that the negative part goes to the carbon which has less number of hydrogen. So negative part in HBr is Br, and this Br goes and attacks here, and ultimately you have CH3 forming. So ultimately the secondary carbocation is stable. So assertion is also true, reason is also true, and they are explaining each other well. That's all from my side for today, and this is all the details of the channel. Do visit the channel to watch more videos. This is me signing off for today. Have a good evening.